Next, we're going to do some examples where we use Taylor and Maclaurin series to compute the sum of infinite series. So I look at this series, I see 1 minus 3 squared over 4 squared times 2 factorial, and then my next one has powers of 4 and 4 factorial, powers of 6 and 6 factorial. So I think, okay, I'm seeing the even factorials, which makes me think of my cosine x series. So remember that cosine x is sum n equals 0 to infinity, minus 1 to the n, x to the 2n over 2n factorial. Or, written out, this is 1 minus x squared over 2 factorial, plus x to the 4 over 4 factorial, minus x to the 6 over 6 factorial, etc. So I see the series that we have, and we see that this is our series for cosine of x with 3/4 in place of x. So we have 1 minus 3/4 squared, so 3 squared over 4 squared times 2 factorial, plus 3/4 to the 4th, so 3 to the 4th over 4 to the 4th times 4 factorial, etc. So this entire series, it's our series for cosine with x equals 3/4, so this is just equal to the cosine of 3/4. And now again, this is useful because if you need to know the cosine of 3/4, that's not one of the exact angles on your unit circle. So you're simply going to take this series on the left, add up the first several terms, and that gives you your decimal value for cosine of 3 to the 4, cosine of 3/4, 3 over 4. Okay, so in our next one, we have sum n equals 0 to infinity, so this time I've given it in sigma notation, 3 to the n over 5 to the n factorial. So I see that n factorial and think e to the x. So I know e to the x is sum n equals 0 to infinity, x to the n over n factorial. We have sum n equals 0 to infinity, 3 to the n over 5 to the n, which we can write as 3/5 to the n over n factorial. So now we see this is just our series for e to the x with 3/5 in place of x. So this is just equal to e to the 3/5. And now just to make sure we all see what's going on, if you were to expand this out, when n is 0 we would get 1, n is 1 we get 3/5, n is 2, we get 3/5 squared, or 3 squared over 5 squared over 2 factorial, n is 3, 3/5 cubed over 3 factorial, etc. So the value of e to the 3/5 is given by this infinite series, which is just our series for e to the x with a 3 over 5 in place of x. Okay, in our next one, again, I've given you the sigma notation. You see your 2n factorial, which makes us think cosine. So we know cosine of x is sum n equals 0 to infinity, minus 1 to the n, x to the 2n over 2n factorial. So we see we've got the minus 1 to the n, we've got the over 2n factorial, and now we have pi to the 2n over 3 to the 2n, which we can write as pi over 3 all to the 2n. So this is just our cosine series with pi over 3 in place of x. So this is just equal to the cosine of pi over 3, which we know is equal to 1/2. So this infinite series is equal to cosine of pi over 3, which we know is equal to 1/2.